All right. Hi, everyone. We'll get started here in just a few moments. All right, just a few reminders as we're getting everyone on board. If you don't mind introducing yourself in the chat. And when you do so, at the bottom where it says to, make sure you set that to everyone so that everyone can see your messages and your comments in there. Just introduce yourself, where you're located, say hi to everyone for that awesome networking that we love to do as teachers. We will get started in just a minute or two once we give everyone time to get into the session. If you are just joining us, please introduce yourself in the chat. At the bottom of the chat window, please make sure you set the to everyone so that everyone gets to see your messages. Looks like we have people from all over the US, Australia. That's awesome. Thanks for joining us today. All right. Well, we're going to get started here. So just some housekeeping things here. Our session will last approximately 30 to 40 minutes. There will be some questions and answers at the end. This session will be recorded and it will be emailed out for anyone that was registered. Whether you attended or not, you'll get that link so that you can check out the webinar at your own time. Also, again, a reminder, if you're just joining us, please set the chat at the bottom of the chat window to everyone so that everyone can see your questions or comments as we go through there. Also, if you have questions, please leave them for the panelists in the Q&A section of Zoom, and we will answer those during the Q&A portion of our session today. Also, very important, hang on for the end of the session. At the end of the session, we will have a giveaway at the end, but you have to be here. So please hang on for the end of that particular session. All right, so our agenda for this session is we are going to go over a kit overview. We're going to talk about our content that goes with the Blueprint kit. We'll talk about additional resources, as well as have our question and answer session. And of course, the very important part of the giveaway at the end. Our presenters for today, we'll start with Adrian.
Hi, everybody. My name is Adrian Emerson. I'm an education content manager here at Sphero. Before my career at Sphero, I taught in a public high school for 14 years. I taught math, engineering, robotics, and coached the competition robotics teams that were at my high school. And I still kind of have my hands in competitive robotics in my downtime when I'm not here at Sphero. But I'm super excited to tell you all about Blueprint today. I always, when I'm talking about Blueprint or building things with Blueprint, I always give it the highest compliment I could give, which is my classroom would have been better if I had Blueprint in it. So I'm excited to show you all the cool stuff that we have in our Blueprint products line today, and I'll let Brad introduce himself.
All right, thanks, Adrian. So my name is Brad Fessler. I am the Professional Development and Content Manager here at Sphero. I worked in grades 9 through 12 technology and engineering classroom for 15 years. I spent 4 years in higher education, as well as a curriculum writer for Engineering by Design. So no stranger to the classroom, and Blueprint would have definitely been at the top of my list for things to get in my classroom, because it is an awesome building experience. And hopefully you'll see that throughout our presentation. All right, so why Blueprint, right? So Blueprint is helping bring our students into that engineering world, right? So engineering education is something that is being pushed all around the world. It's more prevalent than it has ever been in our classrooms, whether it's in middle school or high school levels, right? It's there, right? So we bring in all of those current classes or kits that are out there. They're kind of intimidating to a lot of students and teachers out there. A lot of small parts, you need special tools to put things together, or the parts are small. So as you're building, it takes a lot of them to make a substantial structure. And Blueprint tries to move away from that, and it does it very well to make sure that we have some awesome ability to build some cool structures, and rather significantly large structures, very, very quickly. It even simplifies those lessons that could take multiple class periods. So if we're building with some other kind of building kit and we only have enough parts for one class, we build and it doesn't get us through in one class period, well, then you have to set that to the side, and then other students can't use those pieces until the first students are done with their build. So that we want to be very, very careful with build kits, because it means you need a lot of them, or your students can't all be doing the same thing at the same time. Blueprint makes it very, very quick to build structures and then take them back apart very, very quickly. So now you can do these lessons in one class period, which is awesome. The process is also driven through problem solving, right? And it's helpful in all kinds of careers, even if our students are not going to see like become a mechanical engineer or some kind of engineering field, no problem. The skills we're learning in that process are useful all over the place. So the Blueprint build kit, it's simple, it has the right number of parts, so it doesn't have a million different kinds of parts there, like to make some like crazy builds, right? You can do some very complex builds still with just a small number of the right kind of parts. That's the key here, is we have the right kinds of parts with that. I already mentioned it's quick to assemble and disassemble, and we have looked at the standards that we are trying to teach, and that is what has driven the development of all of the product line. So it's not build a cool product and then what can we teach with this? It's what do we want to teach, and let's build our parts to do that. All right, Adrian's going to tell us a little bit about the build kit and the class pack.
Awesome. Thanks, Brad. As we mentioned, the Blueprint kit is made to be used in your classroom with when you're trying to teach engineering content. And we've really designed this kit and the content that goes along with it for that 6th to 10th grade range, STEM and engineering classrooms. So we're really trying to teach those basic engineering concepts that students in that age range are getting introduced to. I already saw a question in the chat, and I think a few people answered it, but I'll go over this again. Each kit, individual student kit, is meant to engage 2 to 3 students and has about 320 mechanical pieces and parts in it. And also each kit includes a storage bin that rests inside each other, and those sorry, I was hearing an echo with myself for a second. So those nest inside of each other for easy storage in your classroom. In that class pack, which includes 5 student kits and an additional box with extra parts that we call the teacher kit. So it's just extra parts if students need them or if things get lost or anything like that, to supplement those 5 student kits. So each class pack engages up to 15 students and comes with over 1,600 parts. So that class pack also comes with an educator guide. That educator guide is a printed booklet that's going to walk you through how to use Blueprint in your classroom, some tips for lessons and building with Blueprint, and then some additional resources on our content our digital content that we include with Blueprint. Every student kit is going to come with a quick start guide with how to start building with Blueprint. 5 engineering challenge cards, so you can start using these Blueprint kits right out of the box. When you open them up, every single kit will have 5 cards in it, and they're engineering challenges like building an architecturally interesting building with your Blueprint pieces, or making a working fishing pole, or things like that. So you're going to get 5 of those challenge cards in each kit, and then at launch for this kit, we'll have 2 units that are fully complete. And the first one is going to be about simple machines, and we'll talk a little bit more in depth about these units in a minute. But the first one is on simple machines, and the second one is a build your own carnival in your classroom.
Awesome. Thanks, Adrian. So let's take a look at the parts that are in the kit. So this is a truss-based system. So we have different size or pitch trusses. So each one of those little squares on a truss is considered one pitch, and they are 25 millimeters in size. So a 10 pitch truss times 10 times 25, right? This becomes a large build really quickly by assembling some pieces together, which is really pretty cool that you can build something substantial quickly. We also have the weighted trusses, which, sticking with the simple math with using 25 millimeters for a pitch, we're going with 25 grams for each pitch of a weighted truss. So we have a 1 pitch at 25 grams and a 3 pitch at 75 grams. Then we have plates, and these plates are used to reinforce our builds, to add some strength to these. So we can snap 2 10-pitch trusses together and then use a plate across them to make it substantially stronger with that. We also have a bunch of different kinds of connectors. So the stock red connector just allows you to connect pieces together. It snaps in there very easily. It can be removed using the removal tool, which we'll get to in just a second. But then we also have lock plates, bearing plates. Those are useful with shafts. Those little shafts that are there, or axles, right? They can be used to lock them in place or allow them to spin inside of your build. We also have turntables, which allow for that rotary motion. And then we also have hinges for angular motion to be able to snap things and move them around. When we're adding in some more mechanical concepts, we have lead screws and the lead screw nut. So now you have that rotary motion to move things and turn it into a linear motion if you wanted to. And to support the linear motion, we have that linear motion bracket, which allows us to create some really cool sliding mechanisms. We have 6 different length shafts, and then we have shaft collars that are either half or quarter pitch that just snap right onto the shafts, as well as high strength shaft collars. So if you're going to put them under some load, you can actually tighten those down with a set screw that is used using that removal tool. So no need for an additional screwdriver or anything like that. It's one tool in the system, that removal tool. Then we also have our gears, and pulleys for some more rotary motion. And we can add a 100 mm tire to the 90 mm pulley if you want to get things on the go. We also have a hand crank to give more input into that, and some rope and rope clamps to be able to facilitate moving those pulleys. All right, in the next slide, Adrian's going to talk about some blueprint build kit content.
Thanks, Brad. That was awesome. I get so excited looking at the blueprint pieces, and especially saw in the chat a lot of people talking about the removal tool. And like Brad said, it's the only tool that you need to work with the system, and it makes disassembly so easy. And you can use it in 4 different ways to help you remove different pieces. And so it's really very, very versatile. So I'm going to talk a little bit more about the content that we've been creating for Blueprint. Like Brad said in the first slide, we've really used this opportunity of developing the Blueprint product line to really get back to what the standards are that are being taught in these Intro to STEM and Intro to Engineering classes, and designing our product and our content to hit those standards in a simple and easily approachable way for students and teachers. So when we have our so for the build kit, which is our first kit that we're releasing with Blueprint, we're gonna at launch have over 50 hours of standard aligned lessons, and we have aligned all of our lessons to the NGSS standards and the STEL standards. So both of those are national sets of standards for engineering and technology, and so we've aligned all of our lessons with those 2 national standards. And our 2 unit plans at launch are going to be an introduction unit plan for simple machines. So showing you how to build simple machines, showing you what they're used for, and then a more fun and creative unit called Build Your Own Carnival, where students are going to be using everything that they learned about simple machines to build carnival games and rides, which has been really fun to develop, let me tell you. So in that simple machines, we all of our content will allow you and your students to build and explain and identify working mechanical models of all of the simple machines. So if you noticed in that parts slide, there is a hand crank and there's pulleys and there's gears. So we wanted to make all of these models working models so that just using your hands, no wiring, no programming, no power, all of that stuff, you can just make these things move with your own 2 hands and really tactily understand how these things work. We really focus a lot in the simple machines unit on calculating mechanical advantage and helping students understand why simple machines help your mechanical advantage. And then we also add in a little bit of physics and math and do the calculations for mechanical advantage. Brad pointed out in the parts list that we really tried to make math not an intimidating part of this system, right? So our pitches are 25 millimeters, our weights are in 25 grams. And so all of the ratios that they're working out for mechanical advantage aren't like a million decimal places or anything like that. So, you know, I think that that makes the system and the content much more approachable. And then we work in compound machines where you combine more than one simple machine into a compound machine to complete a task. So we get into those compound machines in both units, the simple machines and the build your own carnival units.
Awesome, Adrian. So I think a common question that comes up on this topic is, so we're talking a lot about the mechanical engineering and a little bit about the less intimidating math side of engineering, but are there other curricular topics that are linked into Blueprint lessons?
Yeah, absolutely. I think if we go to the next slide, I can't remember if it's on the next one. I think it's on the one after this. So, but yes, we really try to work in some cross curricular examples into our content. And so we really tried to focus on 3 main things in our content creation. And those themes were past engineering developments, emerging engineering tech, and also career connections. And a lot of times, those historical aspects and those emerging tech concepts really bring in other content areas such as history, English language arts, and then obviously math and science. So and I see a question right now, and I'll just answer this really quick. Are the lessons available now? Some of them are available on our resources page, and all of them should be available by the end of the month. So you'll have some time if you want to implement Blueprint into your curriculum next year. You should have some time this summer to look through those lessons. So in our lesson format, we include 3 different levels of lesson. And so they're kind of explained here on this slide. So some of our lessons are considered a level 1 or a foundational lesson. Those type of lessons are meant to be completed in one class period. One of the most frustrating things that I found in my engineering classroom is that when we were trying to teach simple concepts where we had to build things, it often took multiple class periods to make one tiny connection. That was a really important connection, but it kind of gets lost when you're spreading that over multiple days. So we really wanted these foundational lessons to be one and done, 45 minutes in a class period. Some of you may be double blocked, but in case you're not, if you have 45 minutes in a class period, we want you to be able to understand how that simple machine works, be able to build it, be able to disassemble it, and finish up your exploration for that concept in one class period. So these foundational lessons really focus on introducing one small topic that is in our content goal. So like one simple machine, one part of mechanical advantage. And again, these are going to be very quick builds, and all of our level 1 lessons come with build instructions. So students are not trying to create this build from just a picture, or they're not trying to invent something of their own to show this concept. We're going to give you the build instructions, which we'll show a little bit later on, that are interactive, 3D, and really help students to be able to build these working models very, very quickly. Second type of the next, I guess, level of lesson we have is level 2, which is called exploration. These are designed for 1 to 2 class periods. We wanted to keep it flexible for you. So if you don't have a lot of time to go over these, you can keep them to 1 class period and just kind of truncate the activity, or you can do the whole written activity in usually about 2 class periods. And these cover more in-depth concepts of engineering. So we've introduced a simple concept in a level 1 activity, and then we're bringing it to level 2, and these are more open-ended with some support. So maybe we'll give you instructions of how to build like the base of some sort of simple machine, and we'll have the students invent something to go on top of it, but they're not just starting from scratch, because again, we really wanted to make the content and the system really approachable and non-intimidating. And sometimes for kids, when they're first entering into engineering, just starting from nothing and having to build something is really intimidating. So we always want to try and give them something to start with. And again, these content connections, we really tried to incorporate historical engineering, emerging tech, and career connections into these lessons. And then our last level of lesson is a level 3, and that is a creation. So now we're really starting to get into the really creative part of engineering. So these are designed to be like unit end projects and could take up to a week of class time. And in these lessons, we want to connect multiple types of engineering concepts to serve your students and kind of putting everything together. So think about it as you maybe have in a unit, you have a ton of level 1 lessons. You have a few level 2, and then 1 level 3 kind of at the end. And then these are more open-ended building challenges where we're really trying to guide students through the full engineering design process, brainstorming, prototyping, recording their findings, and coming up with a final design. So I think we're good for the next slide.
All right, I just want to jump in here and answer one of the questions that I saw come through the chat, because I think it fits in here really well. The question was brought up, do the lessons go over why these mechanical concepts work and how they work? Or is it just, hey, build this and kind of learn it through osmosis?
That is a great question. So that is part of why the blueprint kit is, I think, so special, is that because these pieces are big and they all have like really specific features, it's really easy to see why these things are working, and being able to calculate the mechanical advantage in a lot of these simple machines is showing how and why these simple machines make work easier. But my favorite example, if this is my first plug, I'm going to have at least two more. But if you're coming to ISTE, we'll have our blueprint engineering kits there, or I'm sorry, our blueprint build kits there, so that you can see them and play with them. But when we were at some conferences earlier in the year, we have a build. The very first lesson in Unit 1 is on inclined planes. And we made the build so you can really easily switch between like a really high angle incline plane and a really low angled incline plane. And we have a rope connected to one of those weighted trusses so you can pull it up and down. And just being able to lift that angle up and tug on that rope and pull up that weight, you can significantly feel the difference in how difficult or how easy it is to pull that weight up based on the angle of the incline plane. So that to me is kind of where the magic is in this kit, is students can feel that difference immediately when they're building this. And then they go into the math part. Okay, so what does this mean from like a math perspective and this mechanical advantage thing? Oh, my mechanical advantage on this really high ramp is super low, and my mechanical advantage on this on the low ramp is super high. And so they can see how easy or difficult it is to lift it actually translates into like numbers, which I think is pretty cool. Great question.
Yeah, that's awesome, Adrian. Thank you for the explanation. All right.
Yeah, lesson format. So all of our lessons, first of all, are available as Google Docs. So it's either a Google Doc or a Google Slide. There's a few reasons why we did this. One, we want you to be able to use these lessons exactly as is and not do any work to them if you don't want to. But if you do want to, we want you to be able to do those that easily. So we are not in your classrooms. You all know what is best for your kids and in your classrooms. So if you need to take our content as a starting off point and make some changes and make it into your own, we want to give you the ability to do that. So all these are available in Google Doc form. We also know that in your classrooms, some of you have super virtual classrooms where everything is submitted through Google Classroom or Clever or some other learning management system, and you want a paperless classroom, so you want to deliver everything digitally. You can do that with all of our Google Docs. But we also kept in mind that a lot of you don't want to do that. You want to be able to print things. You want to have it in your hands. You don't want your kids to be on a screen. Maybe they don't have one-to-one technology in your classroom. And so you don't have all of those screens available. So we want you to be able to print them out. So all these are designed to be used as a Google Doc, or if you print them out, they will print on a standard 8.5 by 11 sheet of paper on a black and white copier or color copier, either one. So that's the first thing. Second thing is that every single one of our lessons are going to come with 4 different resources. So the first one you see here in that little GIF that's moving, that's an example of some of our build instructions. I mentioned before that they're interactive and they're 3D, and they are linked on the web if you want to be able to utilize that interactivity and animation. And so they are web-based, and you kind of click through and you can see every time something moves in that GIF, we were clicking a button to move to the next step. But just like I said, we know that not all of you have one-to-one technology or want your kids on screens for your whole class time. So all of these instructions are also going to be available in a printable PDF format as well. It might not be quite as interactive, but we did want to make that available to you. The next resource we're providing with every lesson is in the lower left-hand corner there, and that is teacher slides. So along with every lesson, we will have a teacher slideshow that you can put up on your projectors, and again, be able to use it right out of the box or be able to change it and make it more applicable to your classroom. The next two resources, the one right in the middle, it says Simple Machine Teacher's Guide. That is a teacher guide that's going to walk you through and give you all the information that you need about that lesson. So how long it's going to take, the standards that it's aligned to, your learning objectives for your boards, any additional materials that you need for that lesson beyond just the piece of paper and the blueprint kit. And then it's going to give you step by step of what is in what that lesson entails. Then on the right hand side of your screen, the last resource we give for all of our lessons is a student handout. So this is directly aligned with that teacher guide, the build instructions, and the slide presentation for students to work through all of the design and math and physics and everything from that lesson. So those are the 4 resources, again, that we provide with every single lesson. You're on mute, Brad.
Whoop. There we go. Awesome. Thank you, Adrian. Appreciate that. So we've built some cool things. We've followed some lessons and learned all about simple machines and maybe went further. But what do we do after that? Well, a big push right now in education is industry certifications. And CAD is a huge industry certification that's out there and achievable for high school students to work through and do that. So we are supporting some CAD curriculum with our Blueprint Build Kit. We are supporting Onshape, which is a free, full-featured online drafting program. We're also supporting SolidWorks and pretty much any 3D modeling program out there by supplying a step file. And if you're not familiar with the step file, I'll equate it to the PDF of the CAD world, right? So you can import this into other CAD platforms and work with it. So we will have CAD specific content. We are giving away all of those parts in a digital form, in an Onshape document, the step file, or in a SolidWorks. And what that allows you to do is create your own assemblies, and then even using our starter part files, build your own custom 3D printable blueprint parts, which is really cool that you can build all of your own parts. So you really want something cool, like in this animated GIF on the far side, we have a pirate ship ride that you might be familiar with at a carnival or an amusement park. And what pirate ship is complete without having a pirate flag on the top of it? So we have our Sphero pirate flag on the top of the pirate ship, which was a custom made 3D printable part. And we've done this in a very user-friendly way. You can use some variables in Onshape to make these starter parts larger or smaller to help keep you on pitch so they can attach to Blueprint no matter how large or small you make the part. And they are 3D printer friendly. So from that software, you'll be able to export that STL and work from there. So some really cool, awesome ways to expand way further and teach them maybe higher level concepts as well.
Yeah, that's awesome. That's been one of my favorite resources to develop for this product. It's been super cool to work with. So before this is our last slide before our giveaway, but I wanted to talk about Blueprint Build and beyond, and just some questions that I've already seen in the chat, and just a few things to kind of get you thinking. So I saw a few people asking, what about electrical components and power and making these things move? We wanted to keep the Blueprint Build Kit really, really simple. And sometimes those electrical components can be intimidating to students and teachers. But hang tight, because you can see a little preview on the screen of one of the electrical components that we will be releasing in the next year as part of our blueprint engineering kit, which will include power and other electrical components. So stay tuned. And if you are coming to ISTE, here's my second ISTE plug. If you're coming to ISTE, we actually will have prototypes of that system to showcase at ISTE. So again, these are just prototypes, but you can come see them at ISTE if you're going to be there. So are there any plans to make more blueprint mechanical parts? Absolutely. Again, blueprint kits are meant to be super simple and not provide you more than what you need to teach the content. But as we continue to progress our content into more advanced engineering, we are going to be developing more blueprint mechanical parts. This is definitely meant to be a product line. We're not just stopping with the blueprint build kit. But that doesn't mean that the blueprint build kit is not going to give you exactly what you need for those intro to STEM and intro to engineering classes. But we do want your blueprint kit to be able to grow with your classes. Is there more content coming? Yes. We're going to be providing content for all levels of engineering education. So as we release more mechanical and electrical parts, we're going to also increase the amount of content that we offer for those subjects. And last, can I use grants to get blueprint? Absolutely. So blueprint, again, is an engineering kit, which is designed to be used with CTE curriculum. And there are tons of CTE funding and grants available. This presentation is going to be sent to you guys, and that link on there is going to take you to all of our resources that we have to help you find grants and funding for CTE parts, including Blueprint and other Sphero products. But for example, some of the big players out there are Perkins grants, ESEA, and ESSA. So if you're familiar with any of those, Blueprint would qualify under any of those grants as a CTE tool to use in your classroom. So I think we've gotten to most of the questions that were in the chat at the beginning. But if there are any other questions, please go ahead and put them in the chat right now so that we can answer them.
All right, let's address a few that stood out that maybe didn't get answered yet. The question was brought up, can we use little bits with this, or can we interface other robots like Bolt and Rover into here? So I'll share one of the experiences that I've had with our sales team at some trade shows where we were building some fun things with Blueprint, and we built a fan build, which is using some gears. We're talking about gears and gear ratios in there. And we actually put Bolt in a little cradle that we built out of Blueprint parts, and had used Bolt as an engine to drive the Blueprint mechanical side of things and spin our fan. And then to integrate, because we always have to bring more into it, right? The fun part was we added little bits, and we added the proximity sensor behind the fan. So every time a fan blade would go around, it would flash an LED that was built into it. So very creative uses of the different products that can very easily be added into the kit while we're waiting on some of those other cool electronics.
And I have another, in terms of integrating, if any of you have participated or heard of the Sphero Global Challenge, which is a competition, a virtual competition that we do here at Sphero every year. In the Bolt and the Rover Plus Sphero Global Challenge for this year, which just got released a couple weeks ago, there's actually Blueprint integration in both of those challenges. So I would definitely, if you're interested in having Blueprint interacting with those products, I definitely encourage you to check out the Sphero Global Challenge Season 4, because we have lots of great ideas for that in those.
Awesome. Thanks, Adrian. Another question that just popped into the Q&A section here is, what is the format of your lesson plans? Meaning, do we have like a curriculum focus, like the engineering design process, or do we use a 5 or a 6E model that you might find in the engineering by design curriculum? what does that format look like for us?
So our format is really in, oh man, I wish I had a picture of it. So while we know that everybody has to have some of you have freedom in your lesson planning formats, and some of you maybe have to have it in some sort of format. So we tried to keep it as easy as possible for you to use in whatever way you can. So we really tried to separate our lesson plans into categories. So we have launch for the beginning of your lesson, construct, which is actually building and constructing whatever it is in that lessons, interacting, so interacting and learning from that. From whatever build you have, and then and we have a few other categories that I can't remember off the top of my head, but they're just kind of separated into categories of how you would walk through the lesson and what the students are going to be doing. So they're not necessarily in a specific format, but again, we're giving them to you as Google Docs so that if you need to edit them to be in the format that is required for your school district, or in a format that's easier for you to read, you're more than welcome to do that.
Awesome. Thanks, Adrian. Appreciate that. All right. So I'm just looking to see if we had any others that are bouncing around out there. All right. I think that answers most of our questions on that. So let's jump to the next slide here. There we go. So if you want to learn a little more about Blueprint, we have an FAQ page here, as well as a resources page that you'll be able to go check out a bunch of different things that are out there. Adrian, do you want to elaborate at all on what's out there as far as content on those?
Yeah, so all of our challenge cards that I mentioned that come in the kit, the challenge cards are already up, and each challenge card has a student handout that you could even take the challenge card further. And like I said, there are some examples for our lessons up there already. I believe there's 3 lessons that are already posted on that resource page with all of the lessons uh, scheduled to be up there by the end of this month. So you can also look at all of the different resources we talked about as far as 3D printing and CAD, all of that. If it's not up there yet, it will be up there sometime in the next month. And you can also find all of the pre-order information on there, standard alignment information on there. And so basically anything you need to know about Blueprint is going to be in one of these 2 places.
Awesome. Thanks, Adrian. All right. The super important time that everyone is interested in, right? So let's go through, and it looks like Vic Wilson. Vic Wilson, congratulations. You will receive a Blueprint build kit once they start shipping. So hang tight for that. We'll get some information out to you, and you'll receive a build kit in the near future. All right. So thank you very much for everyone joining. There will be some PD certificates available that'll come out in a follow-up email, so hang tight for that. Also, we want to talk about our ambassador program. So you can apply to be a Sphero hero right now. That application process is underway. So if you are interested, get to our website and check out the Sphero Hero program. We're always looking for people that are using our products in very unique and cool ways, and be an ambassador to help spread all of these awesome, fun activities that we can do with our students to schools all around the world. Also, if you want to learn more about anything or any of our products, check out sphero.com. Check out all of our socials, our blog, and you can join our email list at the footer of our website on there. So please stay involved, and we appreciate everyone coming out today and joining us for this session.
Thank you, everybody. Have a great night.